Okay, this is an equilibrium question in which we're told about a specific equilibrium, in particular this one involving ethanol and ethanoic acid, and then we're told some information about how we calculate the amount of acid that's been completely used up by a titration involving barium hydroxide. And obviously when we do this calculation we need to consider that there's two hydroxide ions produced, which would mean whatever concentration or whatever number of moles was actually used up, it would be actually double that. And in a second experiment it was repeated using 0.5 moles ethanoic acid and similar amount of ethanol. We need to calculate the equilibrium constant, the percentage yield of the ester, which is on the right hand side, using this information, and then discuss how the equilibrium concentrations of the mixture in experiment 2 differ from 1. So these questions can seem a little tricky initially, but the thing is just to get started on doing some calculations, and as you go through usually it gets easier. Right, and so what I've just set out here, some of the calculations to get started on. Now working out the number of moles of barium hydroxide is just going to be using C equals NV, which changes to V times C equals N, or moles. So we're just going to multiply the volume, which got to make sure you do it in litres, and just a little error there, that's times by 0.094 moles per litre, and that's going to equal 2.89 times 10 to the negative 3 moles. Now remembering that this is moles of barium hydroxide, and as we want it for 2 moles of hydroxide we just need to double that to get 5.78 times 10 to the negative 3 moles. Now the other information we've said is that this is the acid in 1/100th of the reaction mixture, so we need to times that by 100. So that's just a matter of really shifting the decimal spot there a bit, and we'll end up with 5.78 times 10 to the negative 1 moles. Okay, so that's the first part. It's worth thinking about what this actually means though, because if we look at this equilibrium here, the titration was done with the acid that was left over, that did not react to complete this reaction or to make this ester. So this is the amount that is actually the residual, so to speak. So how much did actually participate? Now we're told it's 1 mole per litre and of ethanoic acid, so 1 mole of ethanoic, and if we subtract 5.78 times 10 to the negative 1 moles, okay, that's, well, it's making it sound a little more complicated than this. It's just 0.422 moles that actually did react and go across to help form product on the other side. So as the moles, if that's the number of moles that went across, then we know that's the amount of moles on the side, 0.422. Okay, and then we know that this must also be the amount of moles of water, the amount of moles of alcohol, and the amount of moles of acid on that side. So okay, now this can get a little confusing, but obviously if 0.0422 was used up and 0.0422, because it's a 1:1:1 ratio, of this was used up, that means on the right this is the absolute concentration of the ester here, absolute concentration of the water, although and this is the amount of acid that's left over, because we started with 1 mole, and if we subtract 0.422, that's what we're left with here. We had 0.5 from the question amount of ethanol, and if we subtract 0.422, that means we're left with 0.078. Okay, moles per litre of ethanol. So we've got concentrations of both products and reactants. Now we just need to put that into the equation which is going to be products over reactants, and that's simply going to be, now it's a simple matter of putting it into a equilibrium expression, Kc rather. Now this is an homogeneous equilibrium system. Homogeneous means they're all in the same phase. These are all liquids. Ethanol, ethanoic acid, the ester itself, and water. So we include all of these in the actual expression. So when we write out the equilibrium constant, we do include water, which normally we'd think of excluding in a heterogeneous system. That's where there's a mixture of solids, liquids, etc., and aqueous. So that's where possibly you're likely to go wrong in this one. So once you've got a basic understanding of that, you just need to replace these with numbers and do some calculations, and obviously that's going to be fairly straightforward. Okay, so now if we just set that up again and just change it in terms of putting numbers in, so we just replace it with 0.422, 0.578 for the ethanoic acid, and for the ethanol we have 0.078, should have had another square bracket around that, but anyway, we get a whole number of 3.95. Okay, now we're asked to also work out the percentage yield for the ester, and that can be done relatively straightforward because we start off with 0.422 moles of it. Now that's 0.422 moles. Now we've got to find out what was the most we could get. Now this is a 1 mole of ethanoic acid to 1 mole, so it's 1 mole to 1 mole, that gives 1 mole of ester. Now we have a higher number of moles of the ethanoic acid, so the limiting reagent here really is the actual alcohol itself. So when we make this comparison, we use the 0.422, we divide it by the number of moles of the ethanol, because that's the one that's going to be the limiting reagent in this reaction. It's going to, how much of that is going to really determine how much of the ester gets made. And if we turn that into percentage, we get in the region of 84.4%, something like that, which is actually pretty high. Now, in the second part of the question, we're asked to discuss, with reference to the K expression, how the equilibrium concentrations of each component of the mixture differs from the concentration in experiment 1. Now, the only thing that's really obviously significantly changed here is the fact that the amount of ethanoic acid, instead of being 1 mole per litre, as it was initially, is now gone down to 0.5. So this is really the same as decreasing the amount of a reactant. And we kind of know what will happen in terms of an equilibrium here. It's going to shift to the left, and if that happens, we're going to get less acid, and we're going to, less ester forming, and less water. Okay, so that's the first thing to realize. Now you should talk about everything. So obviously, if it comes over to the left, we had 0.5, which is the same amount of alcohol, so that will actually increase, and also the amount of yield should decrease. Obviously, if it's shifting to the left, we'll be aware of that as well. Okay, and that's really all you need to discuss in terms of part 2, and that's that question.